Hello, ladies and gentlemen. Today we are going to write equations of lines. So some more review of our linear functions. We need to write equations of lines today. Given some special pieces of information, you need your notes and probably a calculator for this. Make sure that you're writing down those examples with those little pencils. There's a couple formulas that are really important today. So what if I asked you to give me directions to Starbucks? What else would you need to know? What would you need from me? Well, you probably would need my starting location where I'm at, maybe even which Starbucks I want to go to. So there's some key pieces of information you need before you can describe to somebody how to get there. The same applies when we write equations of lines. There are some key pieces of information that we need or that we talk about when we're talking about linear equations. So when we write equations of lines, you need to know a few key pieces of information about the line. When you do that, when you know some information, then you can use slope-intercept form or point-slope form to get you started on writing that equation. So if I'm going to use slope-intercept form, y equals mx plus b, remember the m is the slope, the b is the y-intercept, those would be my key pieces of information. Or I could use point slope form, which requires me to have a point and a slope as my key pieces of information. Make sure both of those are written into your notes. And now we'll go ahead and do our first example here. This one's a graph. You don't need to write all of the words there, but just maybe sketch the graph to the best of your ability in your notes. And we are going to write in a slope-intercept form equation here of the line shown on this graph. Now the slope-intercept form, ooh, let's go back. Just kidding. How about this? How about I'm going to get a pen first? There we go. The slope-intercept form starts with y equals mx plus b. And I need the m and the b from my picture over here from my graph. So the m is the slope. I'm going to go ahead and select two beautiful coordinates here. This one and this one would be nice so I can count my slope. Rise up 3 over 1. So my slope is 3 over 1. So far I'm here. Now I need the b. The b is the y-intercept of the graph. So it's where the line crosses the y-axis. That is at a 5. So I have y equals 3x plus 5 as the equation of my line right there. That one is in slope-intercept form. We usually like our lines written in slope-intercept form because they're handy for graphing as well as substituting if we ever get to that point here where we need to substitute a system of equations. They're handy when it's in y equals form. So let's look at a second example. Write the equation of a line that passes through a given point and has the given slope. Now in this case, we're given a point and a slope. So it might be handy for us to use point slope form. Point slope form looks like this. Y minus y1 equals m x minus x1. And again, you probably remember this from algebra last year. And we want to make sure that we remember that the y and the x are coming from the coordinates of the point and the m is the given slope. So when I plug in my points and my slope here, I'd have y minus the y from the point, negative 5, equals m is a 3, and then we'd have x minus x from the point, which was negative 2. Now in this case, I need to fix this a little bit because I'm subtracting negatives, so I'd have y plus 5 equals 3, x plus 2. Now this is a nice equation of a line, but many times when we're going to do something with this later, it's handy for us to make sure that this is written in y equals mx plus b form. And that would be our focus for our work that we're going to do. I would like these written in y equals mx plus b form. So to get there, you would want to distribute the right side here, so 3x plus 6, make sure that you distribute that. And then we're going to go ahead and subtract that 5 over. And we have y equals 3x plus 1. So the equation of the line in y equals mx plus b form, or slope-intercept form, is y equals 3x plus 1. So notice our b value we found by plugging it into that point-slope form and then rearranging the pieces there to get the y alone. So let's go ahead and do a third example here. What if I have 2 points and I want to find the equation of the line that passes through them? Well, in order to write the equation of a line, either form, y equals mx plus b, or point slope form, we need to make sure that we have a slope. So my first step would be to calculate my slope. So here's my slope formula. Y from the second point is 7, minus y from the first point is 3, x from the second point is 4, minus x from the first point is 2. So 7 minus 3 is 4. 4 minus 2 is 2. So it's looking like my slope is going to be 2. So once I know that, then I can choose to do the point slope form here since I have points and a slope. So I'll do y minus y1 equals mx minus x1. And for this, I'm only going to use one set of coordinates or one point. I can choose my favorite, so maybe this one. And I use that one when I plug it in. So y minus y from my chosen point. M is my slope of 2. X minus x from my chosen point. And then now we want to make sure that we distribute and get the y alone here. So we'd have y minus 3 equals 2x minus 4 when we distribute. And then I'm going to go ahead and add that 3 over here. So my y is alone. Y equals 2x minus 1. So this is the slope-intercept form. It tells me the slope and the b, or the y-intercept. It would be handy if we needed to graph this line quickly. All right, and our last example ties into our geometry idea of parallel and perpendicular. So example 4, write the equation of a line that passes through a given point, like 4, 1, and is perpendicular to a given line. Okay, this line right here is a line that we could sketch a graph of, but we want to find an equation of a line perpendicular to that exact line right there. So to do this, guys, we can first use the given line to help us out a little bit. We need a slope. We always need to start with a slope. And I don't have anything in here that's going to give me a slope except this guy right here. This line has a slope of 1/3. And I need to make a line perpendicular to this one. That means I need to make a line that has the opposite reciprocal slope. So instead of 1/3 like that given line has, I change it to -3/1. So opposite and reciprocal. Or you can just say -3 if you want. So right now I know my slope has to be -3. And I have this given point right here, so I can once again use point slope form to find the equation of the line. So my point slope form, I'll write it one more time here. And I'll go ahead and plug in my values. Y minus y from the first point. M is the slope we just figured out to be -3. X minus x from that given point. And then again, we'll go ahead and distribute so we can get the y alone. -3x, +12. Be careful. -3 times -4 is +12. And then we'll add that 1, add that 1. Y equals -3x plus 13. So I can see now what the b is. I see the slope. And again, we can sketch that graph really easily, just like the other line that was given. Okay, so this is our practice on writing these equations of lines given certain parameters. So we're going to practice this in class a little bit, get familiar with the different types of questions you can be asked, but I want to thank you today for taking great notes.